Let's examine the structure of the superconducting cable of the nucleotron in greater detail. Inside, there is a metal tube in which two-phase helium circulates. It is a few millimeters in diameter. The tube is wrapped with 1 or 2 dozen superconducting wires, which, in their own right, are unique products. It represents a copper matrix which has several thousand filaments made from a niobium-titanium alloy as thick as 6 to 8 microns. We at JINR don't have the capacity to produce those wires, but the technology to do so is available in Russia. We get the superconducting wire from a producer. Superconductors, or the superconducting wires, are tightly pressed against the metal tube by use of fixation wires. On top of it, a 40 microns thick polyimide tape is overlapped for isolation. Around the exterior, the entire assembly is wrapped with epoxy-enriched fiberglass. A special coiling machine produces the superconducting cable in its entirety, when, in one operation, the tube is wrapped with all the components of the superconducting cable. Ultimately, the so-called raw cable is wound on the reel, and it is ready to produce superconducting windings. For instance, for a dipole magnet of the Nika booster, about 70 meters of the superconducting cable are needed. Therefore, this cable is delivered to the winding production section. The operation current of the nucleotron magnet amounts to approximately 10,000 amperes. The number of turns in the coil is 10. Therefore, the magnet strength is around 100,000 ampere turns. The size of the aperture is 100 millimeters. The field size is up to 2 Tesla. To create a field of the required form in such an aperture, it is necessary to position the turns with great precision. The positioning accuracy of the superconducting coils amounts to several dozen microns. For each of the coils to be placed in the exact required position, special lodgements are used during the production of the superconducting winding, which have the flutes for each of the coils. During the production of the winding, the superconducting cable is manually stacked in these flutes on a special turning table. The coil is wound by the fiberglass, and this whole assembly is ready to be baked in an oven. This process is essential for the epoxy compound, which is enriched with fiberglass. To achieve the final polymerization, several dozen hours are spent on the baking process in special temperature conditions. During this time, the temperature varies and reaches a maximum of 200 degrees Celsius. Once baked, the winding is ready for the first trial. Its electrical parameters get verified, namely, the inductivity is measured and the winding is checked for turn-to-turn short circuits. We also monitor the physical dimensions, because the winding has to be clearly and tightly assembled with the iron yoke. After the checks are carried out, the winding arrives at the magnet assembly line, where it is ready for assembly with the magnet yoke. The iron yoke of the nucleotron magnet is designed to form the profile of the magnetic field, as well as to lock the backflow of the magnetic induction vector. Here you can see the physical magnet. The longitudinal length of this magnet exceeds 2 meters. The rate of change of the magnet field is 1 Tesla per second. Meanwhile, considerably eddy currents may emerge in the magnet body. To avoid this, the magnet yoke is made up of a number of ordinary electrode transformation steel sheets, less than 1 millimeter thick. The sheets are cut by use of a laser or a special press tool at the rolled sheet factory. metal shavings and excess ridges are removed, which is followed by combining them into a complete assembly, and they are then fixed into a primary unit by means of welded seams and bindings made with side plates of stainless steel. After that, this assembly arrives at a 3D milling machine. First, the reference surfaces are treated, and then the final handling of the magnet working aperture takes place, wherein the requirements for manufacturing accuracy amounts to 24 microns. We obtain a magnet yoke from a producer and check the geometry parameters in this area.